All right, that's getting captured. So this is a Google spreadsheet, and I have the students in here, and then the assignments with the grade values, and there's some usernames and passwords off to the side there that you're going to use to access the what's called a source code version control system called Subversion. And today in lecture I'm going to talk about that, and I'm going to demonstrate how you're going to use that this quarter. But you will need a username and password. And so I'm going to send all of you your usernames and passwords. And I think it is right there. Email all student passwords. And this takes about a minute or two to complete. So that's, oh, that was fast. I want those people who have access to their email right now, just to check, make sure that you got a username and password. And while you're checking, I'll just show you how I put this together. This is, not the script gallery, sorry. There is this is a Google spreadsheet. They have Google Docs and other Google things, and these are scriptable. And I have, in fact, scripted the spreadsheet. And this is a script that I wrote to do what I just showed you. By the way, did anyone receive an email? Anybody check? Did anybody not receive? So nothing yet, right? Okay. As soon as someone receives an email, let me know. It might not be working, because I haven't tested. I'm testing it now. See, here, this is an event here on open. So this is called. This is also referred to as a callback. It's a function. It's a function. It's a function that. So a function contains a collection or a list of commands or statements. And the statements, by default, they execute in order, one after another. But you can interrupt that order of execution with branching statements or looping statements. So looping statements let you re-execute over and over again a group of statements. And a branching statement lets you take one of several different paths, based on the state of the program. And but anyway, here's a function, and we'll talk about functions. I mean, in our textbook, which lays out the sequence of topics. And we are jumping ahead a little bit. I think it's chapter 5, something like that, where we talk about functions. Maybe it's chapter 3. We talk about implementing functions, but we'll need to use functions right away from day one. But here's a function. It's called onOpen. It has this collection of statements that execute, and these statements run when the spreadsheet opens up. So when I go to that spreadsheet and view it, then this function runs, and this is running on Google servers. It's not running on my local machine. And here we get a reference to the spreadsheet, and then we build this. We build an array of menu entries, and you can see push to App Engine, email single student grades, and this is the one I selected down here. Email all student passwords. That's the item that I selected from the menu. So I created the menu, and which is done right here with this add menu function on the spreadsheet object. And I passed into it, I tell it what name I want for the menu, and I pass into it that list of menu entries, menu items. Anybody receive an email? Nothing yet?
No.
Believe it. Okay, let me check this here. So let's do a little debugging together. Here is on email single student password, on email all student passwords. So I can see here I create a message box, and it's a question, mail passwords to all students, and then that function returns a response. and I give that a name. I call it the choice. That's the user choice. And I compare, and that's a string, and I'm going to compare the string to cancel. Is the user canceling the operation? If the user is canceling the operation, then we present a message box that says operation canceled, and then we return. I'll just show you how that works. Email all student passwords. There's the message box. I'm going to click cancel. It says operation canceled. Now there's the code running right there. So let's suppose we don't hit cancel, then we're going to hit OK. And this is called, it's like I'm checking the logic of the program. This is called an assertion, actually. See, this message box will only return either cancel or OK. It won't return anything else. Well, that's what I think. Oh, so let me code what I think directly into the code. And if what I think is wrong, I will get a logic error right here. So rather than just believe myself, I'm going to doubt myself and embed code right in the program that causes the program to fail if what I believe in is not correct. So that's called an assertion. And in this quarter, we will be, or you will be, writing assertions to test things like this, just like that. It won't be in this form. It'll be in the form of an assert statement. It'll be one line. So it'll look a little bit differently. So here I pass through this business, and I call email password. This is a loop, and I have this variable called row. We'll be looking at for loops shortly in the class, and we have this variable called row. Initialize it to the first score row, and then what is going on in here? This is, the loop is always true. You know what? I'm not gonna get into all the details because everyone's gonna get lost here. Let me try something else. You can help me test a little bit more. I'm gonna try a different function, which is to email all student grades. There's something wrong there. That message came up too quickly. I know that it has to take a lot longer than that. So there's something wrong with, I think it's this email function right here. This is the email password, and this is that send mail function. Let's see, where is... So anyway, I'll debug that later. It's anyway, that's just, I don't want to get too much off on a tangent there. All right, I'll give you that information later. All right, let's come back to the topic of today, which is subversion, and that's what we do in Lab 2. So those students are going to lab today. You're going to continue with the Lab 1 exercise. But with this extra information of Lab 2, assuming that I can get that emailing function working, and I think I can, that you can actually start Lab 2 today. So it's possible to get an early start on all the assignments and labs in this class because they're already defined and on the web. So the idea there is we want to stay a little bit ahead of the deadlines. So I need to cover material before the deadlines. All right, so here is I'm just going to go through this and talk about the lab actually. So this is the lab's called Subversion. And basically I have to log into your account and do some stuff. Also what I'll do now, I'll illustrate how you can do your lab work from home. Or, right now. In class here. You don't have to be in the lab. But you need to be able to log in remotely to one of the lab machines. Actually, you can work locally as well, so I can talk about that too. So on OS 10, you can bring up a terminal window, and I have one running already. To find that, you just go into your in your applications, and there is I think there's like a utilities. There it is. You're going to bear with me a little bit because I don't normally use OS 10. And I think there's a terminal. There it is, terminal app right there. So for those who have Macintoshes, you can use that. So now I'm locally running this console window, this terminal window. You can see PWD, just like for those who went to lab on Monday. And you learn the PWD command, print working directory. It tells you where you are in the file system hierarchy. That all the commands that we use in the Linux lab also work in the same way on under OS 10, because they both share common operating system type, which is called Linux, or Unix rather, Unix. So Linux is a variant of Unix, and OS 10 is based on, it's either FreeBSD or OpenBSD, I can't remember, but those are two other variants of Unix. And so these are Unix commands. PWD is a Unix command. LS is a Unix command. And I'm going to, so I could work, actually I could do everything locally here. And it'll work. It'll work because I have a C++ compiler. But if you have a Mac, you know, the operating system doesn't come with the compiler installed in it. You need to install that, and you get it through Xcode. So you go to the App Store, and for most versions of OS 10, Xcode is free. There was a version in which you have to pay $5 for it. So that's and if you're working on a Mac and you want to learn how to use that, you can talk to me. But one thing that we're going to use, well, from the Mac anyway, is Secure Shell, and that comes pre-installed. So that's available on all OS 10 computers. And we need to, what we're going to do is log into one of the lab machines. Oh, here. So I need this information. This is SSH, Secure Shell. And so Secure Shell, that means we're going to, a shell is another word for terminal window. And so what we're going to do is access a remote computer through a terminal window. And we're going to do it securely, so they call it Secure Shell. So all the communication between the two computers will be encrypted. We can't get to the lab directly. We have to pass through this gateway computer. So the lab machines are not open to the outside world. But this system right here is open to the outside world. And we can first log into that computer, and then from there we can log into one of the lab machines. So there's the command. It's SSH, and then it's my username, so it would be your username. It's the same username that you have in the labs. @ symbol, and then the name of the host name. Call it the host name. You know what the word host means in computer technology? It just means computer. That's all. A computer that's connected to the internet or a network. So, and this is called the fully qualified name, because it gives you a path to get to this thing. So there are these domains, the edu domain, and under there's a subdomain, and then under there's another subdomain. Finally, this part of the name is the local name of the machine. Okay, I'm logged in here. Now, when we're in here, let me see if I can run nano. It cannot run nano. Just to illustrate that. So on this gateway computer, we don't want people running the compiler and doing things because that machine would become a bottleneck. So these commands that you will need to do the lab exercises are disabled on this gateway computer. So let's go to, from here, actually from here let's pick one of the lab machines. And let's take a look at how do we log, now that we're logged into this machine, we need to log into one of the lab machines. And there's an example right there. So each machine in JB359 has a number. So there's JB359-1, -2, -3, like that, up to -30, and plus or minus a few others. Or plus a few others. So that's, yeah, I just forgot it that quickly. So JB359-8. Well, maybe everyone's going to use 8, so I'll use something else. I'll use 4. And also, Turner is, if you don't enter their username on this SSH command, it will use the username on the system that you're currently logged in under. So you don't have to type it in again there. So we're already logged in on JB359-1. We're logged in there as Turner. So we can omit that from the command. This is saying that, hey, we've never connected to this host before. You want to make a secure connection, which we can't do because this is a strange host. We don't know who we're connecting to. And but they're giving us this fingerprint, a key fingerprint. It's called a public key certificate. And do you want to accept this this public certificate? And we're going to say yes on that one. Although there is a risk to doing that because there could be what's called a man-in-the-middle attack. It could be another computer who's pretending to be JB359-4. All right, so that's a problem. So maybe you wouldn't use this procedure if you were logging into computers that were, say, operating some machinery that was, dangerous to control, because you may have enemies that are trying to hack into your system, or trying to get your passwords, so they might try man-in-the-middle attack. So, but in our situation, I think it's okay to accept that that certificate. All right, now we're logged in here, and that nano command that I tried on GBH3-1, which failed, I think it's going to work here. There it is. It works here, so that's good. And this nano command, this is it's a text-based text editor as opposed to a graphical-based text editor. Well, that means that we can run this program inside a terminal window, because terminal windows just send and receive character data. They don't send and receive graphic data, graphics data. It doesn't say where what value a pixel is, whether a pixel is green or yellow, or whether a line needs to be drawn, and so on. It's just sending character information. And I'll do these symbols down here. That caret symbol, that represents the control key. So I do Control X. That's to exit. All right. So in here, you should have a folder called CSE 201. And then after you do Lab 01, you'll have a folder in there called Lab 01. Now we've got another lab to do, Lab 02. Let's make a directory. There is a Unix command that is part of what you need to learn from the first lab. Making a directory. This command works on Windows, on OS X, and Unix, and Linux, and all the Unixes. So it's all the same command across all those operating systems. So CSC, I'm sorry, make directory lab 02. There it is. So I run the ls command again. Ls just says give me the contents of the folder that is current. So you have something called a current folder or a current directory. The word directory and the word folder are synonyms, so they mean the same thing. So the cd command, when you do the cd command, it means to change directory. And so they use D. So in the old days, they used to say directory all the time. It was a directory. But in recent years, it's people tend to use the word folder instead of directory. This is exactly the same thing. Directory and a folder, exactly the same thing. It's like the word host and computer is the same thing. All right, let's go back to, well, we're logged in here. Then I have an example how to run nano. Here we can create a file. Now to get out, you can type in exit. Of course, you could just close your window as well. That's a sloppy way to do it now. But if you type in exit twice, so you have to exit. So we have a console running. We have a terminal window running inside of another terminal window, running inside of a third terminal window actually. So this will back us out to the terminal window on OS 10. So we'd have to type in a third exit to step out of there. So it's one, we're hopping from one computer to another. And in the world of hackers, hackers that are breaking into systems, they want to have a very long trail, so you can't find them. So they're on one computer, talking to another computer, talking to another computer, talking to another. It's just this long trail to where they want to, do some damage or spy or whatever it is they want to do. So this is obviously a common scenario for hackers, but it's also a common scenario for system administrators. System administrators have to basically pass through lots of different networks, and they have to go, they enter in through a private or through a publicly accessible host, and then they get access to a private network, log into another computer, gives them access to yet another private network, and they log into there. So it's a very kind of common situation that you find yourself in. All right. So that's connecting from the outside. Yeah, let's go back to here. Any questions? Yeah.
Will we be able to access what we last worked on in the lab?
Yeah, you can access what you last worked on in the lab. And for those people who were in lab last time, I demonstrated, creating this Lab 01 folder. So it's still there, right? I logged in and, my account is the same as your account. We have the same kind of accounts. And it doesn't matter which computer in the lab you log into, because all of those computers use what's called the network file system. And so each computer is just kind of a front for the data which is stored in a different room. And your work is stored in that other room. So it doesn't matter which machine you log into. Also, if the lab JB359 is occupied, well, you can go to JB358 and access your work there as well. So so both of those rooms are, in a sense, the one room, virtually a one room in terms of the network, the way the network is set up. All right. Let's see here. Now, you will get a username and a password. And I'm going to show you what you do when you get that. I'm going to copy this. This is the command. It's SVN is the name of the command. And then everything that follows the command comprise the arguments of the command. Now, the command arguments generally are separated by spaces. So you'll see that there are 3 arguments. There's CO, that's short for check out, and then there's a space. So you have the command, then you have a space, and then you have the first command line argument, which is CO. Then you have a space. That's called a delimiter. A delimiter is a character that separates a string of characters into tokens. In computer science, you hear the word tokens a lot. A token is just a substring of a larger string. And tokens are normally formed through delimiters that break that larger string into smaller pieces. The first token, or the first command line argument here, is CO. And the second argument, or token, is this URL, a Unified Resource Locator. So that's a way of designating a resource on the internet. So this is a resource that's available on the internet. This is the first part of the URL. That's called a protocol. The protocol, it specifies the way in which 2 computers, well, 2 applications running on 2 computers talk to each other. It's called an application level protocol. And you see the S in there means secure. So it's HTTP, which is the normal protocol for web services, web browsing. But you add an S on there, that means that the data will pass through a secure, encrypted channel. And then you got, this is just a convention here, doesn't give any other information. That's in fact a delimiter. That's what ends the protocol. So there's other protocols. HTTP is a protocol, FTP is a protocol, SMTP is a protocol. There's a lot of protocols that are used for applications to talk to each other over the internet. And so this is the delimiter, : / and then there is the host name. This part of the URL, which follows the second slash and ends with the next slash, that's called the host name. That identifies a computer on the internet. And here, I'm not giving called the domain name. I'm giving the IP address. And that's because this computer is on a network that where it doesn't have a representation in the domain name system called DNS. So we need to use the numeric address of that computer, where your work is going to be stored. This is the address of the computer where you're going to copy your lab work and your assignment work into. And then on this host, you're connecting to a system which is communicating using this protocol. And that system is going to be managing resources. And this here is the name. This here identifies the resource that you want to operate on. And you see it has the same kind of hierarchical structure that you see in the file system. Some sort of root name. Under the root, you've got a subname and a subname and so on. You get any level of naming there. And you finally come down to the local name here, the local name of the resource. And that's it. This identifies a resource that's available on the internet. And finally, the third argument is your local folder name. So we created a folder called CSC 201. And we're going to, what this command does is it checks out, it checks out your repository, which has this local name. It makes a copy of that repository and stores it in the folder called CSC 201. So we're checking out. We're going to copy what's in the remote system and make a copy in your local file system. Let's run the command. Now for this command to work, you have to be in the parent of this CSC 201 folder. Oh, but we are not in the parent of the CSC 201 folder. So we don't want to create a CSC 201 subfolder under here. So we need to go up a level. A CD space dot dot. That means change the directory to the parent folder, to the parent directory. Remember, directory and folder are the same thing. Just to make sure I did that right, I'm going to type in print working directory again. And that's where we want to be. So I'm going to paste in, let's see if that, there we go. I'm going to paste in what I copied from the web page. Now this part of the example command that's on the web, we need to replace that with something that's correct for you. So that's this David Turner, that's my username. And you'll have your own name as the username. But once again, once I get that email system working, you'll receive that name. So you know exactly what to type in there. So here's another security thing. Remember that protocol was specified in the URL was HTTPS. So when you see that S there, you know that you're going to make a secure connection with some other computer. And the standard way to do that is to use what's called asymmetric key encryption. And that requires that the connector have the public certificate of the other system. That's required to make a secure connection. Now we don't have the public certificate of the other system. So we need to say, but the other system is giving it to us and say, this is who we are. I say, well, we're going to trust them. We only have to do this once. And so I'm going to accept this permanently. So I'll type in a P there. Accept the public key certificate this time. And it gets stored away. Maybe David Turner isn't right. Let me try that again. Hold on there. Let me try Turner. That was not there either. Give me 1 second. I gotta look at the passwords there. All right. Oh, okay. 1, 2, 3. All right. Let's see. I am this is what I am. That's my username. So once again it wants to know my repository username here. So this you just enter in. You can hit this password for Turner. I can just go past that. CSUSB DT, and once again you'll get that in your email. Whoops. Rejected. Wait a minute. I'll try it again. No good. Something's wrong. Let's see. Authorization failed. Could not authenticate to server. Rejected basic challenge. So I'm just gonna let me debug now. You can see how to do this, and we do have another half an hour, so we can get this done. This server here, I'll just show you a bit of system administration. This is where we need to connect. I'll just type it in there. 139, 182, 139, and then 99. Host key verification failed. So I stored the public key of this system, and there's a new public key there, and it's okay because I've recently set up this machine, so I created a new machine. So basically, I need to delete my old public key and let a new public key pass in. So that is done like this. There it is right there. So I'm just going to take that line out and go again. So now it's asking if I want to accept that public certificate. I'm going to say yes. My password. And it should be right there. So here's 201. And these are the users. Let's see, I should be in there. I'm going to check that. This is a configuration for the web server. And there I am. And this is where the user passwords are. And this is the name of the groups. And what I'll do is I'm going to set a password here. Unable to update the file. That's because I don't have permission to access that file. Let me show you that. If I do ls minus L for long, that's a long listing. Look at the file here. This is the file called users. I need to modify this file, but these are called file permissions, and those who are going through the tutorial may have read about this already, right? So there's 3 different kinds of user groups. There's the owner, and there's the group, and then there's all other users. And as you can see, that only the owner has right permission, and the owner is root. So I have to be the root. So I'm gonna change to root. I just over your head and all that, but at least it gives you a feeling for what you need to do as a computing professional, right? As a system administrator. This is typical stuff that you do. And so I need to change to root. This is the command on Linux to do that, or one way to do it. And now I use that cd command. So I need to my account on this system where the repositories are stored is under /home/Turner. It's a different path to my account for the lab machines. And let me try that command again. So I'm using the command history. I'm using the up arrow key, down arrow key to scroll through the command history. That's available on all operating systems except for older Windows, but newer Windows machines do it. So let's take let me find that command. There it is right there. That's what I want to run. So this failed because I didn't have right permissions on the user's file. All right, let's see if that worked. I'm going to back out of, see that hash symbol? That means I'm root. I'm going to back out of root. Now I'm still on web 0. I'm going to back out at web 0. So here, look, I'm logged in. First of all, I'm running a shell. I'm running a console on what they call it a shell instance. I'm running a terminal instance on my local machine, which is connecting to a terminal instance running on JBH3-1, which is running a terminal instance connecting to JBH3, JB359-4. And on there, I'm creating a terminal instance, which is on this system that which has the name Web 0. Do you see how we're just hopping forward? So let's get out of there. So now we're back to the lab machine. Let's see if this will work. If this doesn't work, it means that it's not a password issue. Store password unencrypted. Well, that's kind of dangerous to do, isn't it? I'm going to do it. I'll tell you, it's very inconvenient not to store the password. Just be careful. All right. It worked. It worked. And so it was simply my password. So I checked out into here. Now, look, I checked out into CSE 201, but when I look at it, I don't see any difference. That's because my repository is empty, and your repositories will all be empty, and you're going to check out an empty repository. It means you still get something, but what you get is hidden from view. Well, let's see what's hidden from view. So in operating systems, you have this concept of hidden files that exists on Windows, and OS X, all the Unix variants. They all have this concept of hidden files. They accomplish it in slightly different ways. Well, actually, Windows does it one way and everybody else does it the other way. So there's only two ways. And the way they do it in the other way, in the Unix-based systems, is to start the file name with a dot. If I do ls -a, the -a says, show me all. Show me all. Show me the hidden folders and hidden files as well as the regular files and folders. And you'll see this is the control file right there, .svn. So that's actually a directory. The name is .svn. So when you go ls by itself, it's not going to show, it won't show any file or directory that starts with a dot. Did it come in?
No.
Okay. So that's it. Now on Windows, it's different. Windows has a flag it's a file attribute. It's attached to the file, and it's whether the file is hidden or not. So they do it slightly differently. So that's it. Now what we'll do is we're going to go into Lab 02. I'm going to CD into Lab 02, and I'm going to work. I'm going to use Nano. Actually, not there. Let's do Lab 2. Well, actually, this is how I wanted to lab. I didn't want it 02 by itself. I wanted 021, 022. So there's two exercises in Lab 2. And so create one folder for each exercise. So I don't want lab O2. That's not what I want. So I'm going to go out here, PWD, this is where I am. This lab O2, that's not the name I want. So I'm going to move it. Watch this, lab O2. MV is move. On Windows, it's rename. I'm going to move this to lab O2 1. Is that what I asked for? Or did I ask for O1? No, just 1. Okay. And I use ls. I just want to check my work. Did I really get the renaming to do what I want? Yes, I did. So now I'm going to cd into this folder, pwd, print working directory, just to see where I'm at. So we don't have a graphical user interface here. We have a command line interface right now. We're entering in commands, and we're, if we can't remember, if you can't remember, oh, where am I? Normally, you look at your graphical user interface and say, oh, that's the folder I'm in. I can just move my eyes up here and see it. But when you're using a terminal window, you can't just move your eyes up there. It's more like a conversation with the operating system. Where am I? I'm not going to move my eyes. I have to ask it, where am I? And it tells me. All right. So let me just make sure I follow the directions here. Oh, so I'm just going to follow directions actually, because this is the optimized way to do it. So I'm going to go back out of there, and I'm going to make another folder called lab02 _2. Do you see I'm using that history function there quite a bit? Use that up arrow, go back in time, and I edit my command, and I re-enter that. Whoops, that was not right. Make directory. Yeah, see that? I can't talk and work at the same time. That's my problem. And I can't find it. That's too far back. I'm going to make directory. Look at this. I used a command completion. That's a tab key. So there's 3 keys that you're going to use a lot. Well, use enter a lot too. But you're going to use the tab key a lot. And use the up and down arrows a lot. Up and down arrows let you move through the command history. The tab key does command completion. And please, play with the tab key. Understand it. It's very, very convenient in all the different systems that you could work in. There it is. So we have them. And now, let's go ahead and add them to the repository. So this is the command right there. We can copy that. And what this command says, this is the subversion command. Actually, the first SVN, that's short for subversion. Subversion is the name of a version control system, and there are many others. Subversion is convenient, it's open source, it's free, and it's widely used in industry, widely used. It's a very important tool that's used in the software industry. Subversion is the client command name is SVN, but the first argument is the sub command. So actually this is the add command. And then the arguments that follow that modify this sub command, which is to add. So we want to add this folder to the repository. See that A and then the name of the folder? This didn't actually communicate with the remote repository. It's just a local note, like, oh, I have scheduled lab 021 to be written to the repository when you tell me to commit your changes. But we didn't tell it to do that yet. And let's go ahead and add the other folder. The other folder is now scheduled to be written into the repository on the next commit. It's not there yet. And I want to show you, let's see, we have more time. Okay, we're almost done. This resource, being on the internet, we can actually look at it through the browser. So I'm gonna go ahead and show that to you. The site security certificate is not trusted. See, I could avoid this. I would have to pay money to one of the what do they call them? The certificate authorities. Very good. Thank you. I would have to pay money for that service to a certificate authority. And then they would let me sign, they would sign my public key certificate with their public key certificate. And their public key certificate is built in to my browser. My browser has all of the public key certificates of all the important what do you call it again? Certificate authorities. Thank you. I don't have to remember stuff anymore. Oops, sorry. I'm getting too old to remember things. So, but I'm a cheapskate, so I'm not going to do that. But then we're forced to accept that. All right. This is the same username and password that we needed to use on the Subversion command. There it is. Do you want... Yeah, I'm just, it's not a good habit, right? But I go here so often that, and I have my weak password. It's not like that's the password I use when I purchase stuff online. Okay, it's a weak password. So now this is revision 0. That means nothing has been written into the repository. And you see that slash right there? That should be something immediately recognizable to you. That is the root folder, the root container. You see that in so many different contexts. Here, you see it in host names. You see it in file hierarchies. You see it in revision control systems. You just see that everywhere. That's a separator. In Windows, sometimes you see the slash going back the other way. But Windows supports this direction as well. So let's go ahead and look at the instructions. I want to follow this carefully because I would like for you to follow these instructions. You will avoid problems that way. There are other ways to proceed through the lab and accomplish the same end goal, but then you have to know more to avoid problems. Let's see. So I did this, we did that, and then there's exercise 1. Let's go ahead and do exercise 1. We're going to create this this file main.cpp inside the lab021. Let's see, where am I? Oh, I'm there. Okay, let's go to lab021. Oops, not that one. Maybe that'll work. And just make sure I'm there. Yeah, I'm there. And then I'm going to use nano and main.cpp. I think all of our, no, not all of them, but a lot of the programs will have a file called main.cpp. That's the entry point to your program. And let's go ahead and grab a hello program here. Where is the hello program? There it is. Here's the hello program. Okay, there's a C++ hello program. When you learn a new language, you start with the hello program. It just says hi. I think it says hello world a lot of times, right? That's what people do. And now I'm not just going to exit because I have to write the file. So it's down here, write out. So it's Control O and Control O. File name to write, main.cpp, enter, and then Control X. So you really need only 2 commands, Control O, Control X. Of course, if you want to do more editing on the file, you'll need to learn other commands. There is the file, and we can compile that with the C++ command, and that generates a.out, that's the executable, let's run a.out. We have to give it a fully qualified path name. I can't just do a.out. Maybe on your system you can. Let me try it. No, it says command not found. So you have to say, hey, wait a minute. That command's there. You're just not looking in my current folder. And dot is shorthand for current folder. So look in dot, like my current folder, and then slash, that's the delimiter to end the folder name, followed by the file, which is a.out. So executable files are commands. Commands are executable files. It says hello. There it is. So now, let's get that in the repository. And I do it like this. svn add, like that. This command here, let me explain that to you. I'm just making sure that you're in the right place. Once again, you don't have to do it exactly like this, but if you do it exactly like this, it will work. See the tilde, that's that wiggle. It's called tilde, and that's shorthand. Just like dot is shorthand for current folder, dot is shorthand for parent folder, tilde is shorthand for home directory or home folder. So that put us, but we went home folder /201, so we're inside 201. This is my home folder. That's what tilde looks like. And this is the /CSE201 that comes after it. All right, now we're going to do svn add lab02 1/main. That's what I have, right? Let me just check on that. svn add lab02 1 main. There it is. Now it's not going to communicate with the remote repository. Once again, it just schedules it to be written when we do a commit. So we have a bunch of things scheduled to be done. I don't usually use the command line version of svn. Actually, I use the GUI version of Subversion most of the time. So I may not remember all the commands. I think status is one of the commands. Well, there it is, yeah. Status, svn status. This question mark means, I don't know about lab01. You didn't tell me about it. You want it in there, you want it not in there. So that's an unknown. Lab02 a.out, you didn't tell me about that. And so those are questions. But these other three objects, two folders, lab02.1, lab02.2, those folders are marked for addition. And main.cpp is also marked for addition. Now we're going to commit the scheduled changes to the remote repository. And this is the command. Now in here is, a comment. Normally, the purpose of this tool is to work in groups and work in teams. And almost all software is built with teams. Software is huge. Software is thousands, millions of lines of code. So you work for a company, you work in a team, you work with others, and so you need to have a tool, you need to have a revision control system like Subversion. And so you got to communicate with your team members. So every commit has a comment. But in this class, we're just not, you can put a comment in there if you like, but I'm not going to require it. So, but the comments are so important that the command refuses to run without a comment. And so we got to pass in an empty string. See, the quote is a delimiter that starts a string, and a quote is also a delimiter that ends a string, and everything in between comprises the string. So if we have two quotes next to each other, then that's called an empty string because it's a string with no characters. Let's commit. And look at that. It added this folder, it added this file, it added this folder, transmitting the data, committed revision 1. So the revisions, in Subversion, revisions are numbered. And so as you proceed, the number of revisions increases. one at a time. Let's go to the website. Well, that's not really a website. And I don't see any changes. Well, that's because it's a stale web page, right? We have to tell the browser to ask for the web page again from the server. So that's what that refresh is for. Oh, there it is. Look at that. And look, revision number, we're revision 1. We have the 2 folders. This folder has main.cpp. We can open that up, and that is in fact our code right there. Now, when you work, you do the adding, you do the committing, and then check to make sure that the work is there. Okay, because we're going to check out your work and grade your work. So it's common that you think you committed it, but it didn't get there. So you ended up not getting the point. So please use your browser in the way I'm using it now to verify that your work is in the repository. So we're looking at what's in the repository. Now what's locally, I'm just going to do this fast here. Instead of saying hello, let's say bye. You don't have to, I think I'm in VI here. You don't have to, what's going on? Something crazy here. Uh-oh, uh-oh. Exit. No. I don't usually use this. I'll show you what I usually use here. This is so much easier. And but actually it's hard to learn. Save modified buffer. No. Usually use VI. And that's a lot easier to use. So just go down to here and change word to buy. If you're a system administrator, it's very useful to learn VI because it's everywhere. It's on every system, every Unix system. Now, if we compile and run, it now says buy. Of course, it doesn't say buy in the remote repository. Maybe you did some work and you forgot to commit, then we don't see your work. So you can do your work in increments. You don't have to finish everything all at once. You can commit, do changes locally, commit your changes like that. Let's go ahead and commit our changes. And I want you to commit your changes from this folder here. This is the easiest folder to commit from. You're at the top of your, what's called your working copy. And it's just svn commit -m, empty string. See, I saved my password. I didn't have to enter my username and password again. It's all been cached and insecurely saved on my local system. Now we see, once again, you don't see the change because this is a stale web page. We need to refresh, and there's the buy. That's it. That's the hardest system administration. That's all the system administration you need to know for this class. You need to know nano, SSH, CD, make directory, and a few simple subversion commands, and that'll get you through the rest of the quarter. So the first 2 weeks of the class really is centered around learning those tools. All right, we'll see you in lab.